Okay, so today, guys, in our function unit, we're going to be looking at lesson 6 from Illustrative Math, which is features of graphs. We also pulled some examples from Regents exams and some other ones just to kind of go through. So there's a lot of vocabulary here. So if you need to pause at any time, please feel free to do so. Okay, so today's learning goal, let's use graphs of functions to learn about situations. So we're not going to deal too much with situations today, but mostly just the parts of graphs. Okay, so a little review from the last couple days, function notation. So this slide probably looks familiar. I totally borrowed it from one of our last lessons. So it's all about inputs and outputs when we're dealing with functions, x's and y's. So for here, when we have this rule, y equals f of x, the function name for this problem is f, and the input or the x value is what goes in parentheses, and what it's set equal to, that's the y. Okay, so we have to just pay attention to that when we're looking at some of this notation. So before we get into the parts of graphs, I just wanted to make sure that we touched base again a little bit with evaluating a function from a graph. Okay, so we did this a couple days ago. Some of you may or may not remember it. So we're going to go back through again. So here we have function g is this nice curved graph, is represented by that graph. Evaluate the following. Okay, so the first thing that they're asking us to find here is f of -2. So I remember from that previous slide, and I just realized that these are two different names. We're going to call this function f, since apparently I changed the name here. Okay, so when we have this, when we're in the parentheses, that's dealing with an x value. So looking at this, f of -2, this is giving our x value. So when we're given an x, we have to find the y that goes with it. So when I look at my graph, and here's my 0, 0, my origin, I've got to go over to -2 for my x. There's no graph there though, so I've just got to follow it up. And if you need to draw a line when you do these, you absolutely can, but I'm talking about this point right here. Excuse me. When my x is -2, I have a y of +4. Okay, because it's talking about this point, and we just have to be careful with the scale here. The point -2, 4 is on that graph. The shape is called a parabola. Okay, we're going to be spending more time with these later on this year. Okay, so when x is -2, the y is 4, and now I can evaluate that function. What I'd like you guys to do now is you're going to try this next one, f of 4. Okay, so if we're finding f of 4, this is in parentheses again. So that's an x. So if I go to my x-axis and I find 4, I'm going to follow it up to where it hits that graph. Okay, so where we hit this graph up here at this point, that point would be +4 for the x, and then the y, when I follow over, is 16. So when x is 4, the y is 16. And now I have that output. Okay, so we can also go the other way too. And apparently I called these both g's. So we're going to pretend that this is now function g. It's the same graph though. So looking at this first one, now we want to determine the input value of or values when g of x is equal to 4. Okay, so this looks slightly different than the last one. This time we're looking for the input value or values. There could be more than one. So that's talking about the x, which means that this time, guys, this is a y. So they're giving us the y and we have to find x. So I've got to look at the graph a little differently this time. I've got to pay more attention to my y-axis. So the y-axis going straight up and down here, and oh, I see a 4. So we're talking about right here. But the y-axis, guys, we want all of these numbers right here across that line. All of those points have a y that's equal to 4. Okay, so we have to look left to right. When I look at that, I can see that there are 2 places, this point right here and this point right over here, that both have y's that are equal to 4. One of them happens when x is -2, okay, because when I follow down, that's where it shows up, and the other one at +2. This graph is very symmetric, which is why that's happening. So looking at the y values then, we can also find the inputs. So now what I'd like you guys to do is try out this next part. Determine the input value or values when g of x is equal to 0. Okay, so this one is telling us when our y is equal to 0. So where y is 0 is on that x-axis, and there's only one point where this graph touches the x-axis. It's right there at 0, 0. So when x is 0, the y is also 0 for that one. Okay, so now we're going to get a little bit more into some vocabulary. So some of this vocabulary should seem kind of familiar. Okay, and we're going to use it to help us describe events as we kind of go forward with this unit. So the first thing that we're going to look at is 2 words, minimum and maximum. Okay, so they're like reversed here. I just realized that. It says place an X on the maximum point. Okay, so when we see maximum point, what that's talking about is the highest point on the graph. So when I look at this, it kind of looks like a roller coaster. It's like up and down and up and down. Okay, but it gets to the highest point right here. So I'm going to put my X right at that point. And then there's 2 follow-up questions about it. The first one, what is the maximum value? So when they're asking maximum value, they want to know the y value. So for this one, the highest this graph gets to is up to 1, 2, 3, 4, 5, 6, 7. At what x value does it occur? So now I want to see, where does it happen on the graph? So if I were to follow this down to my x-axis, it happens right here at -1. Okay, and that's because this point up here is the point -1, there's our x, 7 for the y. So the opposite of maximum is going to be minimum. Okay, so minimum would be the lowest point. So now we're going to put a little O on the lowest point. So when we follow this down, it comes down, goes back up, comes back down, but it's not as low, goes back up, comes back down. So the lowest point on this graph is this point right here, which is the point -1, 2, 3, 4, 5, and then down 1, -1. So what is the minimum value? So just like we did with maximum, it's really asking us for the y. So what is the minimum value? Well, it's 1 below the x-axis, so it's going to be -1. At what x value does it occur? So now we're talking about the x. Well, I already labeled the point, so that makes it pretty easy. Okay, our lowest point, our minimum, happens when x is -5. Okay, so these should sound familiar. We see maximum and minimum in other parts. We dealt with them a little bit in inequalities. Like if there was a maximum amount of money that someone could spend on something, that was the limit. That was the highest amount. Okay, so it's the same idea here. Just looking at the highest point for maximum, lowest point for the minimum. Okay, so now you guys are going to try one out. So the graph, we're going to see this a couple times. What is the maximum value of this graph? So what is the highest value it goes to? Okay, so looking at this one, the highest value is going to be up here at this high point right here. We're talking about, though, when we want to know the maximum value, is we want to know the y. So this graph went up to 1, 2, 3, 4. So 4 is that maximum value. And we're going to see this graph again in a couple minutes. Now this one should look familiar to you. State the y-intercept. Okay, we talked a lot about y-intercepts when we were graphing lines. Okay, and a y-intercept, whether it's a line or a squiggly graph like this, it's where your graph crosses the y-axis. In other words, it's where x is equal to 0. So if I find my y-intercept, I've got to look at the y-axis where x is 0. And just like I had to do for other points on my warm-up questions and on the last question, I've got to look up to where that graph is. And right here is where this squiggly graph crosses our y-axis. So what number does it cross at? 1, 2, 3, 4, 5, 6. So a lot of times when we're dealing with y-intercept, we just want to know what the y value is. If we were to write that as a point, it would be the coordinates 0, 6, where x is 0 and the y is 6. So it depends on how they ask the question. Usually this is sufficient. What's the y-intercept? 6. Okay, if they ask for the coordinates, then you would write the point. Why can a function only have one y-intercept? Okay, so let's think about the definition of a function again. Every x can only have one y. So if we had two y-intercepts, that would mean that x equals 0 has two y values, and we can't have that. Okay, so it also, if you think about it another way, if we were to throw, I'm just going to throw another point on here. If that point existed, this would not pass the vertical line test. Okay, because you would have 2 points crossing that vertical line. Okay, every x can only have one y. You can't have 2 points when x equals 0 or 3 or whatever. You can only have one. So you're going to try it out. This graph should look familiar. Okay, same one as we looked at before with the maximum. This time though, what is the y-intercept? Okay, so y-intercept, where we cross the y-axis, where your x equals 0, however you want to think about that. We're talking about this point right here. So our y-intercept for this problem is going to be positive 2 because we are 1, 2 units above that x-axis. Okay, a little more vocabulary. This is a big one for us. We're going to see this a lot this year. Okay, and there's like 3 different names that they call these. X-intercepts, zeros, solutions. Ooh, one more. Just thought of it. Ooh, don't need that line. Okay. Another one that sometimes we see is roots. And they're all talking about the same thing. When we think about the last problems where it was the y-intercept is where we crossed the y-axis. One of the names here are x-intercept. So it's where we cross, not we, the graph crosses the y-axis, or sorry, x-axis. It's where y is equal to 0. Okay, that's where that name zeros come in. Okay, so we're going to see solutions and roots a little bit later on this year more. For right now, probably x-intercepts and zeros will be the most common. Okay, we want to state all values of x where f of x is equal to 0. Guys, they're giving us right there, that's a y. Okay, f of x is really just a fancy way of saying y equals 0. So we want to state all these values. Well, if it's an x-intercept, I'm going to be looking at my x-axis. Okay, so right here it's labeled. I've got 2 places where I cross my x-axis. That's it. So there's only 2 zeros for this one. But I need to say what they are. I have to state them. So here's my 0, 0. So let's see, I've got -1, -2, -3. Oh, -4 is one of them. And -5, -6 is the other. Okay, so whether they ask us for x-intercepts, they ask us for zeros, they ask us for where f of x is equal to 0, so written out in function notation, we're talking about the same points, where your graph crosses the x-axis. So now you guys are going to try one out. I kept it kind of simple for this one. How many zeros does this function have? So how many are there? So you're going to count up how many zeros. So zeros are just another name for x-intercepts, where we cross the x-axis. So I've got 1 right here, another right here, and a third right there. So there are 3 zeros for this one. If we wanted to be more specific, which I didn't ask you that, but this one right here is at x equals -1. Then we've got our next one at 1, 2, 3, 4. And our last one at 5, 6, 7. Okay, so zeros are where you cross the x-axis. Now, the next 2 we've definitely talked about before, and you guys have described it previously in problems, and it's dealing with increasing and decreasing functions. So the first we're going to look at is where we're decreasing, and it's saying to highlight. So I'm just going to make this a little bit thicker, maybe. Okay, and where we're decreasing, we want to look from left to right. Okay, and this is going to be where your graph goes down. And we want to look from left to right, just like we're reading a book. And we've talked about this on the previous slides. This looks kind of like a roller coaster where you're going up and down and up and down and up and down. Okay, so we're going to start here at the beginning. The first thing that's happening is my graph is going down until it meets this minimum. So this part right here is where we're decreasing. Okay, but that's not all. Our graph then goes up this big hill, hits this maximum up here, and then I can see it starts to decrease again. So I'm decreasing again here. Okay, last one up here. We're going up, 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 up this little hill. We get to this high point here at the top of that hill, and then it comes down until it stops. So there happens to be 3 places where we are decreasing. Now, the way that we would write where it's decreasing is we would use interval notation, okay, or inequalities. And I'm going to do some inequalities here. So I'm not going to do this for all of them. I'm just going to look at this middle part where we're decreasing. So if I wanted to tell somebody where this graph was decreasing, I would look at where it started and where it stopped. So I just drew lines down to the x-axis. So it starts decreasing at -1. And I'm going to do my less than x. And x has to be less than, this is 0, 1, 2. Ooh, I'm missing a sign there. There we go. And I've seen this with the equals underneath. I've seen it written both ways. I prefer this one without the equals because really at those peaks and valleys, they're not increasing or decreasing. They're kind of staying steady for a second, but you could write it either way. And what this means is that this graph is decreasing in between x equals -1 and x equals 2. And if you wanted to write it out that way, that's fine too. We're going to look at a regions question. You can kind of see how they've asked it, and they did do it in interval notation. So now on the other side of this, well, we could also have an increasing function. Okay, so it's the same function that we just had. Okay, so increasing, and we've talked about this before when we looked at our linear equations. An increasing function is where the graph goes up and same thing, we have to go from left to right. So I'm just going to make my marker a little thicker again. Okay, so I'm just going to follow this along. So the first thing that happens is I started here for the graph and it decreased first, and then I get down to that minimum. But my minimum has got to go all the way up this hill, so that's where I'm going to be increasing. My graph is going up, 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 bing. Okay, then it decreases again. Gets to this little valley here, and then up, it goes up again. So up, 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 and it stops increasing there. So just like we talked about with the last one, if we wanted to tell somebody, where is this graph increasing or a piece where we're increasing, I'm talking about my x values. So I'm going to do this second one. It's a little shorter. Okay, so if I follow down from where it started and I follow down to where it ended, these are the 2 x values I've got to talk about. So the first one is at 2. So 2, 3, 4, 5, 6. So my graph starts increasing at 2 and it stops increasing at 6. So those are the 2 numbers I've got to put on the outsides of my inequality. 2 is less than x, which is less than 6. Or sometimes they throw the or equals to. Both are okay. If I wanted to put this in words, I could say the graph is increasing between x equals 2 and x equals 6. And I only did that for one interval. I could also do it for that first, the larger interval. I just wanted to make sure that you saw how it would be written. Now a regions question with this, and this is where we're going to end today with this vocabulary. So a little story background. We have a ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. Okay, because if you're going to throw a ball, eventually at some point it has to hit the ground. The graph below shows the height y of the ball from the ground after x seconds. For which interval is the ball's height always decreasing? Okay, so look at it carefully. Look at the graph. Look at your choices. Which choice is showing where the ball's height is always decreasing? So when we think about what we just talked about, when we talked about increasing and decreasing graphs, is right up here at the very tippy top of this graph. That's the maximum height, a little bit above 144 feet. So what is happening here is it reaches that maximum height and then the ball decreases. It goes down until it hits the ground. Well, it hits the ground in between 5 and 6 seconds. I forgot what time it was. So this would be 5.5 seconds. Well, it started decreasing in between 2 and 3 seconds. So at 2.5 seconds. So the only one of our choices that's showing that it started decreasing at 2.5 seconds and stopped at 5.5 seconds is choice 3. Okay, so I'm going to post these notes also on your Google Classroom. So that way, guys, you have that vocabulary and you can go back to it at any point. So we're going to be using this vocabulary to help us describe functions pretty much from now on and looking at those key parts of a graph to help us answer questions about situations, kind of like this one. Okay, if you have any questions, please let me know. Okay, take care.